Hi, good morning. Today we'll see Buckingham's pi theorem. So it is one of the tool which is used in dimensional analysis. So dimensional analysis is generally done with the two methods we have seen in last previous session. One method is Rayleigh's method. When number of variables are less than three or four, no, then we can apply Rayleigh's method. Otherwise, we need to go for this Buckingham's pi theorem. Today we will understand, we will see Buckingham's pi theorem thoroughly. So let us see what is the statement of Buckingham's pi theorem. So according to Buckingham's pi theorem, if there are n variables, if there are n variables in a physical problem, in a physical phenomenon, and these variables contains m primary dimensions, that is mlt theta like that, mlt theta like this. So then all the variables are arranged into m n minus m dimensionless groups called as pi terms. So this is a statement of Buckingham's pi theorem. So that means if you take any physical problem, if it contains n variables, if it contains n variables, then all these n variables will be grouped into n minus m dimensionless groups, where m is called as fundamental dimensions like mlt theta. So in other words, now if there are n variables containing m fundamental dimensions, then all the variables are grouped into n minus m dimensionless terms called as pi terms. So that is a statement of Buckingham's pi theorem. Let us see this theorem in detail. Some of the rules and restrictions, like number of terms, now pi terms we can have for a physical problem will be n minus m. So here n is called as number of variables involved in the problem. These variables involved in the problem, and m is called as fundamental dimensions. They are involved in the problem. Like fundamental dimensions will be m, l, t, theta, like that. It will be there. Next one is each pi term contains m plus one variable. So if you see now each pi term, so it will contains m plus one variables, in which m variables will be repeating variables. That means pi one term, pi two term, pi three term will be there. So in all these terms now, suppose if m variables will be repeating, then it is called as repeating variables. So if all pi terms contains variables will be repeating, then it is called as repeating variables. Next one is a dependent variable. So there are rules will be there. A dependent variable should not be selected as a repeating variable. So the repeating variables will be selected in such a way that one should be having geometric property like diameter, length. So diameter, length. Next one is thickness. So all these things will be geometric properties. The other property will be flow property like velocity, acceleration. All these things will be there, and other should be fluid property like kinematic, viscosity, density. All these things will be there. So like this, in general, we are taking repeating variables in such a way that. Next one is the repeating variables themselves should not form a dimensionless term. So we are selecting repeating variables. If see the repeating variables as a group, so if it is forms a dimensionless group, means we should not select that one. Only we are selecting uh, variables in such a way that they should not form any dimensionless term. Next one is must now all the repeating variables must contain total number of fundamental dimensions like m, l, t, theta, like that it will be there. And all the pi terms will be solved by using the principle of dimensional homogeneity. So the principle of dimensional homogeneity is nothing but if you take any equation, dimensions of the both sides of the equation are both same, means then it is called as a dimensionally homogeneous equation. For example, distance velocity is equal to a distance by time will be there. So that implies velocity dimensions will be Lt power minus 1 and distance will be L by T. That implies Lt power minus 1 is equal to Lt power minus 1. So that means the equation is said to be dimensional homogeneity, dimensionally homogeneous. So that is called as principle of dimensional homogeneity. So each pi term will be solved by using the this principle of homogeneity only. Okay. Next one is let us take a physical problem in which there are n variables will be there. So here x1 is dependent variable. Let us assume x2, x3 and x1 are independent variables. So the relation between the variables can be written as x1 is a function of all other variables like this. And we can also written like this also we can write. Next one is here number of variables will be n. Suppose all the variables contains m fundamental dimensions means then we will get number of pi terms is equal to n minus m. So then by considering the pi terms now, by considering pi terms, by considering pi terms, by considering pi terms now, the equation 1 is this. Let us call it as equation 1. The equation 1 will be, by considering pi terms now, the equation will be transformed to, this equation is transformed to like this. Fn is a function of pi 1, pi 2, pi 3, pi 4 up to pi n minus 1 is equal to 0. Or this equation is there now, since x1 is a dependent variable, we can write pi 1 is a function of all other pi terms like pi 2, pi 3, pi 4 up to pi n minus 1. So like this we can arrange the pi terms. We can group the number of variables as per the pi terms. Let us assume x2, this is x2, x3, x4 will be the repeating variables in the physics. Let us assume three variables, repeating variables. If the fundamental dimensions will be only ml, t only, then it is 3. Then the number of pi terms can be written as, let us take pi 1 term. Pi 1 is equal to x2, x3, x4. These are repeating variables. Power a1, b1, c1 multiplied by x1. Similarly, pi 2, repeating variables will be same only. x2, x3, x4, x2 power a2, x3 power b2, x4 power c2, x5. Next, suppose if you want, if you write pi 3 term means we can write x3 power a3 and x4 x3 power a3 x2 power x2 power a3 x3 power a3 and x4 power this is b3 and this is c3 and this is x6. So like this we can write n minus terms and the final term will be written as a pi n minus 1 is equal to x2 power a n minus 1, x3 power b n minus n, x4 power c n minus 1 and xn. So in all these pi terms now, x2, x3, x4, x2, x3, x4, x2, x3, x4, x2, x3, x4, all in all pi terms, these are repeating variables. Next, consider each pi term and apply dimensional homogeneity. We can find the value of pi 1 term, the value of pi 2 term, the value of pi 3 term. So by applying the dimensional homogeneity, we can find the values of a1, b1, c1, a2, b2, c2. Like this, we can calculate those values, and you substitute here, you will get all these values. So by considering the all the pi term, pi 1, pi 2, pi 3, pi, all these terms, no, the equation 1 can be written as like this. Pi 1 is a function of pi 2, pi 3, pi 4, and pi n minus m. The functional relation between the variables will be in terms of non-dimensional numbers. No, it can be written like this. So this is how we are developing relation between the various variables in a physical phenomenon with the help of non-dimensional numbers or non-dimensional terms. No, so this is according to Buckingham's pi theorem. So I hope you understand this theorem. Thank you for watching this video. If you For any further suggestions or for any clarifications, you can contact me. uh, these are my details. Next, for more videos you can subscribe here, at the right side bottom corner. By clicking here you can subscribe my channel, by subscribing the button here. Thank you for watching. Thank you.